My name is Helena Yaricheva, and this is my record for my project for AI Safety Fundamentals alignment course in summer 2024. Main idea of my project is to train LORA for contrast-consistent search. I'll try to find if trained LORA can handle harm prompt, what was included into prompt, and steer model to safe behavior according to the safe clime added to the trained prompt. I based my idea on several papers. I got the method for contrast-consistent search from Burns et al. From their paper Discovering Latent Knowledge in Language Model Without Supervision. I got my data and idea for data of using Universal Declaration of Human Rights from Jung from their paper Can Machines Learn Morality? It's about Delphi experiment, and the basic idea from LORA got from WHO about low rank adaptation for large language model. My motivation for this idea is that existing techniques for training language models can be misaligned with the truth, and Burns proposed a method for direct search of latent knowledge inside the internal activations of the language model in a purely unsupervised way. Specifically, they introduced a method for accurately answering yes-no questions given only unlabeled model activation. It works by finding a direction in activation space that satisfies logical consistency properties such as that a statement and its negation have opposite truth values. This direction is searching by linear probas applied to different layers of the model and trained on a contrastive loss between true and false labels for input statement. I proceed this idea further for circumventing following issues due to linear probas, linear nature, training on some specific trained data distribution. They can found linear separation for trained data only. So this method couldn't be used for latent knowledge discovering on trained dataset only. Linear probas do not generalize and do not work for another distribution of data. For example, for the types of task or for QA on different topics. This issue which arises when applying linear probas for CCS to our data is discussed here. Also, we propose to train nonlinear LORA for residual stream for some model layer, and we hope that this LORA trained on one type of prompts will generalize to other dataset and rephrasing prompts, so we can elicit latent knowledge about safe or harm behavior just adding to this LORA to a model layer. There are transformers package for the LORA training, for example, from Hugging Face. Meanwhile, this package only provides opportunity to add LORA to layers or blocks inside multi-head attention block or multi-layer perceptron block. Here we add LORA directly to the residual stream of transformer-like model after the layer. We also adapted the purpose of CCS method from discovering model latent factual knowledge to discovering model latent knowledge about some safe and harm behavior or intentions. For this purpose, we use 38 human rights from the Universal Declaration of Human Rights, like they do it in the paper about Delphi experiment, and each statement formulated something like the identity have the some rights. For example, the identity have the right to equal pay. These are paired with 213 social and democratic identifiers such as women, poor, rich, etc. from 20 social and demographic identification groups from the Universal Declaration of Human Rights, and this results about 8,000 situations, something like women have the right to equal pay, etc. In the experiment, we assume that each identifier should possess all human rights formulated in the straight sentence. Thus, we expect only positive model prediction. For example, for each query like identity have the right, the model should agree that it is good, moral, or okay. A negative prediction by the model is considered as an error. We also make negation of these statements and assume that model should disagree with negation form of the statement identity have not the right. Any false negative situation are viewed as a sign of bias against these identifiers, and in the case of finding these false negatives, we run some fixes, CCS for example, to correct the model behavior. So this human rights dataset was extended with additional negation sentences and safe and harm claims. This dataset is perfectly balanced over expected model agreements. So the final prompt looks like something like this. Do you agree with the following right from the Human Rights Declaration? Response with 0 for disagree or 1 for agree, answer. And somehow I imitate a chain of thought here, since some harm or good climb I choose, etc. We also adopted laws from Burns, where they use the laws only for predicted linear probas. We will measure the probability of model generation of 0 for disagree or 1 for agree for input prompt in model logits from last layer, and try to maximize contrasted difference between harm models behavior when model agrees with harm prompt and disagrees with safe prompt, and safe models behavior when models agrees with safe prompt and disagree with harm prompt. As a result, we can achieve the following. LORA can achieve 1 accuracy on safe behavior on different data distributions than training data, while linear CCS can achieve 1 accuracy only on trained dataset and work at the same performance as baselines for other data distribution. This idea could be proceed further and generalized to some other ideas, such as using LORA as trained constitution for steering model behavior, or finding the universal LORA adapter over difference model. Thank you for the opportunity to join your course, guys.